continue with 2.3 and talk about weighted mean. This is a lot like the way your grades are calculated. Okay. Remember, so in this class, assessments are worth 75% of your grade. Homeworks or practice, right, is worth 25% of your grade. So the way that that's calculated when the computer does it is it takes your grade that you got out of 100 on your test, multiplies it by 0.75, and adds it to your grade that you got on your homework, multiplies that by 0.25, and you actually get your final grade. It's called a weighted average. Your grades are weighted. So we'll talk about how that works right now. Oh, there's the formula. Hey, we're going to take a class in which our grade is determined from 5 sources: 50% from your test mean, 50% from your midterm, 20% from your final exam, 10% from your computer lab work, 5% from your homework. Your scores are 86, 96, 82, 98, and 100. What is the weighted mean?
Wait, toddlers? You have to find them, you have to do it individually, add it up.
That's exactly how that's going to work. Yeah. And actually, your book has created a really nice looking table that will help you do that. So here, check it out. If you were trying to copy that down, boom. There's a nice way. So this curriculum is set this up as a table, which looks really nice, right? So you're going to take your test mean, you're going to multiply it by the weight. That's going to give you a score. Your midterm multiplied by the weight is going to give you another score. Your final exam, and so on, right? We'll keep going. The sum of all your weights, this thing, had better be 1. If it's not 1, it's not going to work out. It's not going to be a true grade, right? Your grade should be out of 100. If that's not adding up to 1, then your grade's not out of 100, which is strange. No one's ever had a grade that wasn't out of 100. Even though some teachers give you ridiculous extra credit, like 112% or something like that. Yes.
For the formula, let's add sigma.
It means add. It means add them all up. So what it's saying is, right, you have all of your x times w's, this thing, right? And then you're adding them all up. So you're going to calculate it and add them all up.
We're not dividing by this. It says sigma parentheses x plus w plus parentheses over sigma w.
That turns out to be 1.
Oh, sigma w is 1.
Is 1. So it's not going to change anything. Yeah.
So it never does the sigma w ever change?
If your grade is out of 100, it should not.
No, I mean like in any problem. So we got a problem where sigma w is like 3.
I think it is possible if we're not taking it out of 100. Yes.
Oh, we're not going to.
But with grades, if it's a grade problem, it's not going to be. It's always going to be 1.
Will they always let us know that the sigma w equals?
No, you might have to add it up. So there we've seen how that is calculated. Fantastic. Uh-oh. Error was made. Instead of getting an 82 on the final exam, you scored a 98. What is your new weighted mean? So, we're going to have to copy over some of this stuff, right? So we're going to have to go back. Let's see. It was test mean, midterm. So test, midterm, final, computer, homework. midterm, final, computer.
I would have to get it. I don't teach them.
Oh my
Wow, that's a big mistake. B minus, A minus to B minus. Ow. All right, what are the, so the score, let's see, on the final, it became a 98. And then the rest were 86, 96, 98, 100. So 86, 98, 100. This kid was on top of it at home. What were the weights of each?
That's it.
Okay.
0 to 15, 20.
Okay, so we know. So what was the only thing we need to recalculate is the final. What about the test? X times W was
43.
42.4.
14.4. 16.8 or 16.4.
We got to recalculate this one. How about computer? Okay. Okay. Huh?
Yo.
Let's see if it should be fine. Okay, so now we need to recalculate this. You got 91 point something. What'd you get?
91.8.
91.8.
Congratulations, you got that A. Congratulations.
What? No, that's, oh, the total was 91.8. Sorry. We need this. This can't be 91.8.
Mr. Dorn, you kept us up the calculation. The teacher gave him the wrong grade twice.
No, you said the total. You said this is 91.8, right? Is that what you're saying?
Yes.
Okay, let's see. 98 times 0.2, 19.6, so we add it up. And indeed, it is 91.8. And we're dividing by 1, right? So we're just going to leave it like that. There it is. So the new 80 grade is a 91.8. What was it before?
88.
88, and you went from a B to an A. Come on, teach. Double check that stuff. It's important. All right. Hey. Oh. Hey, mean of group data, the mean of a frequency distribution. So what was that like? We want to talk about a class, so we could do this with well, data that we like. If you were to make a histogram, right? If we have, like, sometimes with our histograms, you're grouping them into, like, you know, if you're doing ages, right? Ages 1 through 5, ages 6 through 10, ages 11 through 15, and so on, right? So that's what that group data is. You know what I'm saying?
Where do you go now? But you could buy a house.
Okay, so we've got the midpoint of each class, so we've got a lower limit plus our upper limit. So imagine if we were going ages like 1 to 5, and then ages, or 0 to, let's go 0 to 4, 5 to 9, 10 to 14, right? That 10 to 14 age, what it means by lower limit, the lower limit would be 10, the upper limit would be 14, right? If I take those two, add them, and divide by 2, I've got the middle. You know what I mean? So that's what that is. And then find the sum of the products in the midpoint. So we're just going to, and the frequency. So we're just going to find the midpoint, right? And then we're going to multiply times how many of those are, right? So if I had, well, we said 10 to 14. So what if we're doing ages 10 to 14? We're counting something. If we had 5 people ages 10 to 14, you would multiply 5 times what we got, what, 10, 14, 10 plus 14 is 24 divided by 2 is 12, right? So we would multiply 5 times 12. That's what this is, right? And then we're going to, all these things that we found, we'll add them up. That's what that means. We'll add them up. And then we'll divide. Okay. Yeah, we'll divide by, and that will give it to us. Let's actually calculate these things. It'll make a whole lot more sense. But these formulas are good for when you're working it yourself. Okay, here we go. So if we had a class 7 to 18, right? These are internet subscribers. The amount of time they spent online during the most recent session. So we had 7 to 18 minutes, 19 to 30 minutes, 31 to 42 minutes, 43 to 54, and so on, right? So we did 7 plus 18 divided by 2, got this 12.5, right? How many were in that class? There were 6, okay? So what does that mean? That means 6 people spent 7 to 18 minutes on the interwebs. Okay, that's how you read that. Found the midpoints, found the frequencies. Then we're going to go ahead and add those things up. Or multiply, I apologize. We're going to find those products. Okay. Once you've found all those products, you're going to add them up. That's what that means. It means add all these. And then we'll divide by 50, and that will give us the mean of this frequency distribution. Pretty straightforward. Well, we'll do one together. And then in the homework, you'll do one on your own. Okay, let's see. We're going to use the frequency distribution to approximate the mean age of the 50 richest people. So, we were already given the midpoint. So we don't need to put either. Right over here. Okay. So what are we going to do? Oh, so first, we're going to actually multiply. Right? Yeah. So we're going to do 2 times 38 here, 5 times 45, 7 times 52, 'There's a line missing. We'll go 87. What do we get for each of these? Just to get out a calculator, 2 times 876. 225. 364. 13 what? 87 times 6. 22.
And then you add them up.
We gotta add them all up. So let's go ahead and do our adding. We're gonna add all these up. And then we're also gonna add all these up. Right? So 2 plus 5 plus 7 plus 7 plus 10 plus 5 plus 8 plus 6. We have a sum of 50. Over here, 76 plus 225. Yeah, which makes sense, right? Plus 364 plus 413 plus 660 plus 365 plus 640 plus 522 is 3,265.
When you divide it by 50, right?
Yeah, we're going to find this mean by taking that sum and dividing. Yeah.
Is it rich for 65 years old?
Yeah, that would be the average. All right, let's talk about shape. Symmetric. This is fairly self-explanatory, except for one little thing that is a little counterintuitive, but you'll be able to get over it real quick. So what? If you can split it in half, and one half looks just about the same as the other half of it, then it's symmetric, right? Just like all squares are symmetric. Uniform. They all have the same frequency. So it's flat on top. It is also symmetric. All right, the next one, skewed left. All right, skewed left. It's weird because it's a little counterintuitive, right? Because you see this big hump on the right, right? But what you want to think of is where it's almost like this thing has a little tail, right? So a skewed left distribution is also referred to as a right-tailed distribution. So look at where the tail is. That tells you, right? So if the tail's on the left, it is skewed left. Sorry, I just said right. Yeah, left there. Right, so the tail is on the left. Sorry, I was facing the other way. That means it's left skewed. Okay, skewed left. So that skewed right is going to be pretty much just the opposite, right? If the tail is over on the right-hand side. And it's going to be skewed right. Like that. Right? The tail elongates toward the right, right? So the tail of it looks like it's skewed right. All right. So there's the summary. We determine the mean, median, and mode of a population and sample. Weighted mean of a data set, the mean of a frequency distribution. And we looked at shape of distribution, that's symmetric, uniform, skewed, and we did compare the mean and median for a skewed distribution when we worked on the calculator. So, again.